doors are closed, I think, and it's 16:14, so we'll start a little bit early. So nice to see you here. This session is being recorded, so I can't be swearing too much or tell you too much about Microsoft secrets. I'll try to anyway. This session is a 400 session, so it's not going to be any configuration manager consoles or anything like that. It's going to be only command line, and that's pretty much it. I got a bunch of marketing slides as well, some non-marketing slides. But if you expect lots of demos, you're in the wrong session. If you expect lots of theoretical, how can I reduce the network impact, you're in the right place. Does that make sense? Good. So, who am I? Got my little title or my name up there to the right. My name is Andreas Hammarskjöld. I come from Sweden, from Gothenburg, and I started up 2 Point Software, which is a company we focus primarily on these type of topics, so network management and network content management. Been doing automated deployment for about 20 plus years, I think. The first OS migration I did was from Windows 3.11 to Windows 95, automated, using floppies. So, and we had to increase the RAM memory of RAM as well. Open up each box, dust them with a Hoover, you know. Those were the days. We work very close with the product groups. So we sit on a lot of information that we can't talk to you about. We also sit on a lot of information that we can talk to you about. So I'm going to try to get as much of both of those over to you without breaking too much NDAs. We're talking only about delivery optimization and BranchCache today. There are, of course, as you probably know, 3 elements that comes into play when we're talking Microsoft peer-to-peer. It's BranchCache, which has been around since Windows 7. It debuted. It actually came with Vista, but there was so many other issues with Vista, so BranchCache kind of flew under the radar. Delivery optimization came to the Microsoft platform around 2010. It was actually an acquisition of an American-Israeli company called Pando Networks. And it was bought by the Xbox division. Wonder why. We'll talk hopefully a little bit about that later. And then we got PeerCache Pete, who sits on top of Configuration Manager. So raise of hand, who in here has anything to do with Configuration Manager? Pretty much everybody. All right. So I'll try to tilt towards this a bit. So we have more sessions on the network side of things, 2 tomorrow, 1 at 10:30 with Johan Arvidmark. He will do much more demos of how this sits with Config Manager, how you use each technology. And then Amy Arvidmark is presenting at 2. They're both here as well, so I'll hold them to their sessions that they have to talk about this, but they will also, or Amy will also talk more on how to reduce the network impact for Windows 10. But we're here to talk about theory and how we can make things a lot better. So, who's using DO today? Yeah. Who's running Windows 10 today? In any shape or form? Yeah. So if you are using Windows 10, you are using delivery optimization. There seems to be a big confusion here saying, well, we haven't actually done anything with DO, so we're not running it. That's not how it works. So if you have Windows 10, and if you haven't physically blocked it, then you are using it. And I don't know if who in here attended Johan's session right before this one? Only, yeah, quite a few. So it is pretty chatty. Microsoft is pushing all of their download technologies to use DO. So Visual Studio will stop doing its own thing. Office will stop doing their own thing. Who's using Office Click to Run installer? Yes, so the latest version now comes with delivery optimization support. Intune's coming with delivery optimization support. Config Manager is coming with delivery optimization support. So it's going to be a lot more content. 1703, when you build that out of the box, it downloads about 1.3 gigs, or did a year ago. Before it then went to 1709. And after that, it downloaded another 1.3 gig. Is the story better today? No, it's actually a little bit worse. So if you deploy a Windows 1809 now, it will sit for the next 2 hours or so, or 3 hours. It will try to download, if it can, about 1.4 gig. So what is this data, and how can we make it better? This is somewhat what we're going to talk about. But a lot of people get confused with what delivery optimization is. It's the download technology. It's not responsible for doing the actual, or in charge of the downloads, and says, hey, we're going to use all your bandwidth just for fun. There are programs within Windows that is using this. So this is from a customer of ours, or the customer we were talking to, and they contacted us in panic. Because all of a sudden they see tons of delivery optimization traffic. Network team screaming, everybody screaming. And what was happening is that they had forgotten or didn't know that they had lots of machines in dual scan mode. That was basically upgrading it. And it was peer-to-peer traffic because they hadn't configured DO. Because they weren't using it, they thought. So people get very angry when you take down their point-of-sale systems, because that's apparently when where you make your money. So keep this in mind when we dig into it. So I got a couple of management or marketing slides here to cover, but who in here knows what DO really is? Not a single hand? All right, so we'll recap. It's a download technology, so it's a service. It sits on Windows 10. It's responsible, kind of like Bits. It has a bunch of APIs. The Windows Update and the other consumers say, hey, download this content for me. The DO service then goes up to Azure and talks to its servers and finds its peers to download the content. That's basically what it does. So there is a service that you can disable it, and we're going to talk of why that is a bad idea. And the last point here, fast and furious, is one of the major reasons why Microsoft acquired this technology. So it's if you look at Bits has a technology which is built more or less around a round robin and a simple queuing system internally. It's changed a little bit in the later Windows 10 builds. Now they have an ESE database where they put all their chunks so they can run multiple jobs in parallel, which you didn't used to do. But it was never it was designed to run in the background to do small chunks at a time. With Windows 10, they have to push much more content. Like Windows Store, if you go in and you say, I want to watch this movie, you don't want to sit around and wait for Bits to do its thing and says, ooh, no, I'm going to download at around a meg a minute. You want it to go fast. So they had to do something else. And the reason why the Xbox team bought it, because they wanted this technology to stream videos on the Xbox platform and their larger games that were starting to be like 9 gig, 18 gig, 35 gig in size, which Bits could have probably done, but it would have taken a long time, and then they would have to port that. So instead, they moved it over. The Windows Update team saw that there was lots of issues with Bits, not necessarily that they were related to Bits, but they saw that it was the technology that they had. They saw issues with it, so they were like, maybe if we switch to Windows delivery optimization, we'll get much better success. And they have gotten some success that's better, but there's still some issues. But that gives you a background of where it comes from. So how it works, the consumer, i.e. the ones that wants to use delivery optimization, today it's only Microsoft who is the actual user. That will change pretty soon, where you then publish your content to Azure. What actually happens is that the publishing engine hashes your content, very similar to what BranchCache does, into chunks and sends it up to a server, which is similar in a way to what a BitTorrent tracker is. It keeps track of all the little bits and all the peers and where they're all in the world. So when someone comes to download, the client goes to the tracker, the publishing servers, figure out where are my closest and best peers, and downloads starts tries to get content from those. When it has downloaded the content, it then caches the content as long as possible. So Microsoft, they're not the only ones that realize that content is getting a lot bigger. People have, you know, OneDrive, Xbox, Dropbox, OneDrive, more and more data caching sources, and the cameras get bigger and the disks get bigger. Network is not really keeping up. So Apple has announced, and I think Apple has released their peer-to-peer. Is anyone using Apple peer-to-peer today? So it's one of the major reasons why Apple started was because in school systems, they need to rebuild and get their latest iOS release. They got hundreds of thousands of tablets, for instance. Updating them at the same time. Apple was one of the best. They started with LEDBAT early on to say we're not going to break the network, but they forgot that LEDBAT, the algorithm in LEDBAT, had an issue with latecomers advantage. So if 5 guys are already downloading, a 6th guy comes, the other guy's going to say, ooh, there's new traffic. Then the 7th guy comes on and starts downloading. It means that the 6th guy is going to say, ooh, there's traffic. And it didn't really work on an enterprise scale. So Apple's now doing peer-to-peer. And who else has a lot of Chromebooks? Google. So Google will be doing peer-to-peer too. And the reason is just because there will be much more updates and much more frequent updates. And it's just going to have something you're going to have to get used to. So as Windows is componentizing itself, it will download more and more and more. And it's just going to be the way it is. There's no saying we're not going to do this anymore, because the patching process will move more and more into these individual little components, and if you don't upgrade them, you're not going to be very secure. So on the config manager side of things, they're currently developing this. So it's a bit of a change for the delivery optimization team though, because previously they had one publisher. Now they're getting 60,000 publishers in one go by not allowing SCCM content, because you guys with your config manager servers are going to publish up there. So they needed a bit of change in order to take on such a heavy load, but the service side is going to scale really well. It was just the publishing side that needed a bit of work. Still, there's a lot of things that you do in config manager today that will require changes. So for instance, there's no delivery optimization component for WinPE, but I would expect that to come pretty, not in the first wave. I think they will do delivery optimization support for applications first. So the new app model, that will get it, then packages and program, and the last thing will probably be images and boot images, etc., because that requires the add-on to WinPE. So this is another little slide from the marketing department, but basically here you can track using the Windows Analytics and the Microsoft 365 Analytics the way to see how are my devices, where are they getting the content. And you can see here the little red ring is where you can actually track Office, which is one of the, I think it's the first consumer outside of the Windows world. And you could see that this list will build over time as more and more publishers use the platform. So yeah, Intune as well was also announced at Ignite. And I think this one, if you go to the, or either Google or Bing, or go to the Ignite site to list the sessions for DO, you can see that there's quite a lot of them. These I would say are the most key ones. So 3019, and also if you're using Office, the 3260 session. They have a lot of content on them. So I'm not gonna cover that much more. I think we'll dig in a bit of a demo. So since not a lot of people had seen this, so here we have the service delivery optimization. So that's the guy that's actually doing the work. I think if you click it up, you'll see that the service name is DOSVC and it's run by the service host as a network service. Not much strange about that. In later builds, it stops itself quite often. It's also built around one of the new event logging types, the new type of components that Windows has. No. But, and that means there's no event log. But there is now, and I hope. To figure out which commands that you can run in PowerShell. We couldn't get two machines to run at the same time, so I prepared all of this on my other. So hopefully. Is it visible in the back? Bigger? A little bit bigger? Make it bigger. There we go. So get command. And it's... Thank you, Johan. There are a couple of commandlets that you can run. One of the new ones, I think it came in 1803, is the get delivery optimization log. And it's pretty verbose, but it will give you entries of what actually comes in, very much like the Windows update log. So it's pretty interesting to see there. And one thing that you will see there is that it's working with something called correlating vector. It's so-called CV, and then there's a little short hash in there. It means that using the geo-tracking to know where you are. Because there's no point sending you to peers that sit over in Germany, because, I mean, there's plenty of peers around here. So it's using the geo-tracking to do that. So some people think like, well, I don't want to send that information to Microsoft. But they're pretty open about what they keep. So the service keeps all of this information, but there's nothing that they store. So when you disconnect, that goes away. So it's not something that they store forever to try to use the data. They're using it just to be able to do it as an effective network resource utilization as possible. So if you're having a setup where you're using internet, you know, like lots of small offices, but you don't have any dedicated network, all traffic's going over the internet, you could still use the DO traffic to find neighboring peers down the street using this correlating vector stuff, which is pretty cool. It might sound as an easy thing, but it's really hard for a network from a theoretical standpoint to know that we are close to each other. Like GPS, yeah, but without that, it's actually really hard. So that's why they use some of that. So you can run this, and typically you get this back, which means there's no upload or download. A good way to get some updates and downloads is to, now this is not my machine, so I can do hopefully whatever I want. If I go to check for updates, let's see if we have any. Let's see if we go here. Here you go. So this is typically what you get back. So it works with something called file ID, which is a very long string, but I mean, you can see you got some status, some priority, etc. So before 1803, I think there was no way to bandwidth control foreground downloads. They basically took all the bandwidth that they could. So with 1803, that's now fixed, so you can actually set that. And then you can actually see the URL, and in this case it's pretty easy to figure out what it is. So I can learn here, but this is probably one of the Defender updates. They have the world defo in them, and it's already completed. So if I then run some of the other commands to see what Amy's machine has been up to the last month, we can see that this is what she's been doing. So she's been downloading this month about 2.6 gigabyte This is for a month. So we're talking to a customer. They have machines in rural tobacco plants in Africa. They have a couple of machines, and they have a 128K uplink. And they're like, can we deploy Windows 10 over the wire? And we're like, theoretically, yeah. But once those machines are deployed, you're not going to do any work on them, because they will be taking all of that bandwidth. So it gives you a pretty good understanding of how much data that delivery optimization is trying to take. So an interesting aspect of like what is using all of this data, like what components are there? So we have the Windows Store, right? That's using it. It's all store apps. Which is the most frequently used store app you think on Windows 10? Edge. So Edge is actually a modern app. More and more. Which app do you guys use every single day? Start. Yeah, that's a good one. Another one. Settings. When you connect to Wi-Fi. Yeah, apps. When you unlock your screen. That's apps. Who wants to be the guy that said, I deleted or stopped DO service so we couldn't download any content to update any component, and then they discovered that there's a bug in that Microsoft fixed 9 months ago that everybody else got, that you could just bypass the log screen by holding down Control Shift and F9. I wouldn't want to be that guy. So just turning everything off doesn't stop all the traffic. Stopping the admins, because that's another thing that people think. We're not using the store. No, but you're still using DO to update a lot of stuff on your machine. So that's the key takeaway from the DO side of things. Let's see if we can find, if I do this. Nope. Let's see if we can get something better. Something that hopefully would be pretty popular. Search for jelly is always good. Candy Crush, you can't beat it. I'm going to try to give you a little bit what happens behind the scene here. So even before I launch the store, it's interesting because the store actually starts to download before I actually click, because it knows that I'm interested in this. So it actually goes, before I click get, it actually goes and gets it. So hopefully I'll have time here to go to Microsoft Windows. And this is the first time how you show whether the Windows team built something or it was acquired. Acquired companies end up under Windows current version. Where does the Microsoft people, old time guys, write to? Windows NT current version. So that's a good way to figure out if something was acquired or not. So in here, you can see a bunch of registered keys where it's actually storing and using some of this data. So once the download gets going, we should hopefully see. No, we were too fast. But there's a bunch of registered keys that you can see in here. If I go back to my PowerShell, hopefully you could see that this. So my previous download just vanished away. It just disappeared. But this one is now in caching. So this is the whole peer-to-peer aspect. Once you download something, it starts to cache it. Why didn't the first thing cache? Because it was smaller probably than 10 meg. The default setting for caching anything is 10 meg. Or is it, no, it's still 100 meg. 15? Is it 50 now? Yeah. You might laugh that we don't know the answer to this, but even the actual DO PM, she didn't know the answer. She thought it was 50, but it wasn't 50. And then she said, no, it's 10. And then the team said, no, it's been hard-coded to 50. for a long time. But now it should be changeable, so you can set it, but the default is 50. So as you see, this file size is 83, so it passes the threshold for being cached. And foreground, any job that you do as a user will be foreground. Any other content that will be foreground? When Microsoft pushed panic patches, they pushed them as foreground too. And then you can see your source URL, and then underneath the actual Windows software distribution structure, there will be a folder with this file ID, which will basically host the files in there. Windows files are not they're not encrypted, because there's no real point to encrypt them, because they're available just as regular downloads. This is of course something that Microsoft is going to have to fix going forward if we're starting to deploy other things. We don't want to have a share where you can go and get whatever you want that was downloaded. So that is actually, that came with 1803, but it's not really in the product yet, because there's no point until you can actually do other distributions than Windows ones. Does that make sense? I think that's pretty much on the... See if I find myself back. Did the download. So it is a proprietary protocol. It's not something that's documented. Microsoft tries to get away with this by saying it's a client-to-client protocol. It's not a client-to-server protocol. I might not agree on that, but European Union and the rules say that any client-server protocol has to be documented, but client-to-client protocols don't have to be documented. So, but there's a lot more coming on the DO track, and that's in my later slides. I'll have some more information on that. But it's basically, it's very similar to torrent. Microsoft gets very upset when I say it is like BitTorrent, because BitTorrent has a very bad name, apparently, especially in corporate enterprises. When you go and say it's like BitTorrent, they're like, so we're trying to not use that word, but it's very similar to that. But in 1803, I think it was that version, that's where the encryption comes. So for each release, they're adding more and more component. A lot of them are not visible to the eye, but they're under the hood. And if you look in the event log, so use the PowerShell commands to get to the event log and look at them, you'll see quite a lot of interesting information in there. So we'll be covering a little bit more about DO, but now we're going to talk about BranchCache Bob. Who in here is using BranchCache? A few brave hands. That's good. So I'm not going to cover BranchCache in any details too much. These are two BranchCache both level 400 sessions that I did at Ignite 2017 and 2016 and 2017. They're not the same, so you can watch both of them. They have some overlap, but not much. So, and they're kind of the prereq to know those 400 sessions before we're going to do this session. So hopefully I won't lose the audience too much here. BranchCache has been around for almost 10, 12 years now. And the biggest issues that we've seen is server cache gets corrupted over time. Has anyone experienced that? Yeah, 1, 2 hands maybe. More issues. Companies like to set a lot of policies, and this leads to BranchCache not working. So they try it out, it doesn't perform, they think it's BranchCache, but BranchCache never really had a chance. If you see very low savings when you use BranchCache, maybe 10, 15%, that's typically down to the BranchCache deduplication algorithm on the download side only is saving that data. There's no peer-to-peer traffic whatsoever. And that happens quite a lot. I had a couple of Swedish customers and a couple of American customers that both did this, and they said the savings are not very good. Well, it's not working at all. And then when you make it work, it goes up to about 95% in savings. So it's a big difference. Lately, which is this morning when I was trying to get together to do my demo, on my 1803 patched machine, I couldn't get BranchCache to work. It works on 1809. It works on an 1803 unpatched. And luckily, last evening, I got an email which basically says that yes, Windows Defender, I think it's version 4.13 something, breaks BranchCache on the 1803. It just doesn't work, or it somewhat works and then stops working. So the Defender team has acknowledged this, and they will be pushing a patch to fix it. So if you go home and test this on 1803 and nothing works, it's mostly that you're still using an old Defender. So this is kind of what you will see is when you try to do something on the client and it says no, there's not enough disk space and I'm gonna fall over. So that was pretty much on the slides. Now we're gonna focus a bit on the actual hashing algorithm. So I've got a bunch of scenarios to go through, but it's all gonna be around how can we lower. Is the font size okay for the back? Bigger? Is that good? Good. So I got my little temp folder here where I'm going to do all of my experiments. So my machine's going to be both the server and the client at the same time. So you have to try to imagine what's going to happen when you do this during a download. But the first thing I'm going to do is take probably a little file that I have here. So we'll probably take the data.msi and we're going to create a hash from it using a command line tool. That's basically what the server does. Server sees a request coming in, hey, can you give me the content? It creates the hash and it sends it to the client. And then the client reads that, talks to its peers. In this case, I have no peers, so the client's going to use only its own cache for the content. But it's the same thing that goes in when you're actually doing it. So just going to clean up. And I think I have some sheet. So this is an interesting aspect as well. And I was hoping maybe if the end of the demo, when I'm done with all the slides and the other demos, I can demo my failed machine. But if you try to set this when you have the Defender thing, it basically says, nope, doesn't work. And when you try to do this, it just, nope, it doesn't work. So, well, I'll leave it. I was hoping to show that, but I can't get the two screens working simultaneously. So instead, I'm going to run our dear BranchCache tool. It's a free tool that we've released. It actually came from Microsoft, but it never made actual daylight because God knows why. But it's a full set of all the BranchCache API functions in a command line tool. So anything that the API can do, you can do with this little command line. So it's really awesome. It was designed to help people understand BranchCache and help partners to implement BranchCache, but they never released it. But by running that, I basically say publish a CI, so publish content information, give it a data file, then you just have to give it a content ID, which is just a string identifier for the database, and we're going to squirt out that content identifier into a file. You don't have to do that. For instance, the server doesn't really do that. It takes that data and sends it to the client. It doesn't write a file. But in this case, I'm going to write a file. And I can also give it an actual version. So we'll cover the different versions later, but in this case, I'm going to do version 1. So that completes pretty fast. And if I do dir for my data.version 1 CI, you can see I have a 41,000 bytes of a CI. So that's what the server gives to clients when the client goes and requests the data. with that, I can actually inject data into the cache itself. There we go. So if I run this command, which add data, point it to the data source. You still have to have the data. And that's basically what the client does when it's downloading it, or as it's downloading it. And then I give it to the CI. Then what will happen is it will inject some data, and if you do netch br show status all, you will see that there's a bunch of data that has been injected, and you can see that you have a publication cache status. So this is, we're going to do this many times, so if you feel lost here, it's like, what is he on about? We're going to flush, and then we're going to do it again. So just for the sake of it, I'm going to run these two commands again, because now we're going to start comparing the data. So in this case, you can see here it injected 84,333 bytes into the cache, right? And if I go to my actual data, is it the data.zip? Which one did I do? MSI. Should see that that more or less matches exactly the number of bytes, right? Make sense? Good. So that was using version 1 of the hashing algorithm that came with Windows 7. Now it's going to get more confusing and a little bit more interesting, because this is not very interesting. But now when we switch to version 2 of the hashing algorithm, if I run the same to get my stats, it's 1 meg smaller than the actual file in the cache. And then you start wondering, how could it be smaller? So I'm not going to dig into much more detail here, but leave that and go talking about some of the hashing. So version 1 had a static hashing algorithm. It looked at 32 meg block. If this file was smaller than that, it just did less block. But a segment hash was for 32 meg of content, which was okay. It was pretty good. So if you had multiple of these segments that were similar, it didn't download much more of those content. But if you then actually did put a single byte in front of it, since it's all hashed on a 32 meg or megabyte block level, wouldn't that break the whole thing? So you put one little byte, you make one little byte change in the beginning. Basically the whole hash is invalid and it doesn't match. So that wasn't very good. So with Windows 8, they went back to the drawing board, and it was actually from the server team that they got unsuspected help, because the server team built something that was called deduplication. And the deduplication on storage side, you had a better hashing algorithm. So we're going to cover that in detail. But using version 1 of downloading two, so this is what you're looking at here is a screenshot. It's basically downloading two files that are very similar. Number one, my 1WIM and my 2WIM. You can see the green little stars here means that it did branch cache 100% of the content in there, but in the beginning it's different. So this comes from one of the videos I did one of the session I did at Ignite. So look at those videos, because the WIM files are basically, if you add stuff to a WIM, it's always added at the end. But why did it not get the first bit in the beginning? Because in the beginning, there's a header in the file, and it's an XML header, and the XML header knows exactly how many files and bytes is in the WIM file. So it failed in the beginning to get the first 32 meg block, because the tiny bits in the XML was different. But those couple of stars there, they represent exactly 32 megabyte. From there on, the file was very, very similar, so it could branch cache until the end, where a couple of 1 or 2 meg actual driver that I had added to the same WIM was found, and they're different. Still pretty good savings, right? But now we're going to make it a little bit more amazing. So version 2 came dynamic hashing, which means I think they have 13 patents on this. So it means that they're looking on the file itself, and depending on, it breaks it up in blocks where it thinks this is a natural chunk of data that's most likely not going to change. So it reads the actual structure of the file, applies the algorithm, and makes the identifiers in different sizes. So more or less, if we did the same thing using version 2, the only difference would be a couple of K in the beginning, where the XML headers were different. The rest would match, and then in the end, it would only be a tiny change for the actual driver itself. So this is a screenshot. Even though the names are the same, they're not actually the same. It's not the same files. These are very different files. But you can see that the way that the data is spread across is very different. So what the X's means, that's basically a download of the file. Then it does a second download of the file. But any block that's any color, it means that it found a partial match on the network. And the chunking in version 2 typically is around 100K. So as long as there's a 100K difference, you can get benefit and say, hey, I already downloaded this. So we can benefit this when we're using the Windows 7 and 10 at the side-by-side. But I think I'm going to go back to my little command line tool here and see. So you saw that it was slightly smaller, this guy, right? So let's take something more interesting. Flush in between, go back to my cheating. Then we do a version 1 for the data zip, right? Zip's about 400 megs, I think. So it takes a little bit longer time. Netch, BR, show, status, all. And you can see it injected about 400 megabyte, right? Let's see how version 2 does on that. Oops. So here's exactly the same command line, but at the end I'm saying use version 2 hashing. What's the guess? Is it going to be good, or is it going to be the same? Do you want to, I can make it a little easier. I can show you what's in the zip file. So here's the zip that we're injecting. Here's the data. How much data do you think is going to be in the BranchCache hash? 80? That's pretty amazing, huh? So it saw that the zip file actually contained the same information multiple times. And so if you would have actually used BranchCache to download these 400 meg file, it would only, the client, this is before any peer-to-peer, it would have only downloaded 83 megs. That's pretty good, huh? You all shaved off quite a lot of information. So when you're doing your install WIMs, BranchCache by default with an install WIM shaves off, typically, depends on the SKU, a little bit, but it shaves us about 10 to 20% automatically before it just even downloads it. That's pretty good. So if you have other types of data structures, how does it perform then? So if you do a couple of other demos here, so that was that one. So if I were to do the same thing, you see here, I got all of these Skype versions. They're all different versions. When we copied them, they got funny names, but they're all actually different versions, like 17, blah, 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 up. What would happen if you were to inject all of this? Are the savings going to be good? It takes a bit of time, and we're running a little late, so I'm not going to do it. But these MSIs, they're stored not using a nice algorithm for compression. It's using a LZX, which is a very aggressive algorithm. So even if you make a tiny change to it, you're not going to get any good savings. So if I were to inject this, I would pretty much end up with about 780 meg. If I were to do something with using deflate, which is the algorithm that we use for regular SIPs that Windows does. I have a couple of here that are very small, and if I were to do them, you'd still see savings, maybe 10, 20, 30% savings. But it's really when you're doing larger blobs that the algorithm can find the more interesting chunks. So I got two zip files here, big 1 and big 2. And if I were to do those guys, so basically what I'm doing is clearing out the cache again. And then we're going to inject both of those files into the cache. So let's say we downloaded both at the same time or over time, it doesn't really matter. But the content that ended up in the cache and that i.e. was downloaded is about the same size of one of them. Should have turned that around. Or where's the size? So even though I injected about 110 meg, BranchCache shaved off about almost 50% of that to stay saved in the cache. So the files has to be a little bit bigger for the algorithms to work really well. Tiny files, not so much. So another good example what people do is they do things like this. How do you think a folder structure like this, which is a driver, would perform with BranchCache? It would do pretty well over time, but much better, and we'll probably talk more on this on the tomorrow's session, is to actually zip up your driver packages or any content that has multiple. Use a nice deflate, because BranchCache is very good at finding the differences even in zip files. But you see here, you're shaving off even transferring 2.6 gig is the actual uncompressed size. You compress it down, it goes down to a gig. And even if I have another version, BranchCache will find the differences within that file to only download the delta. Have I lost you completely? So I promised to go back a little bit on Windows 7. So Windows 7 uses the version 1 hashing, which makes that you can never talk to a Windows 2 machine using version 2. Interesting aspect though, a version 2 machine can hand out content to a version 1 machine as long as it has it. So in here we come back to the tools or the PowerShell scripts that we have, which can basically take content of folders, inject them into the cache as version 1 content, so that your Windows 10 machines can serve your Windows 7 machines as long as you have them. And which version or like strategy to go with here is really hard to tell. because it depends how you, if you're just trying to get off Windows 7 as fast as possible, it might be better just to treat them as they are. But if you're still deploying new Windows 7 machines, there's still quite a lot of people doing that, then you probably want to make sure that your like OSD sequences, after they finish in WinPE, they have the version 2 content type. You go into Windows 7, you then inject all of that content you downloaded as version 1 content on your 10s, so that they could serve the 7 machines. The images you don't need to do, but all of the apps, the images themselves will probably come from other Windows 10 machines because they have the same. Unless it's a 7 image, and then you want to do it, so it can serve other ones. So we're running out of time a little bit. We have a PowerShell script that does basically looks at all your TS content and just injects it as version 1 content. So we'll make sure we'll blog about that. But one key aspect to take away is that DO and BranchCache are not competing technologies. They will live side by side and will for quite some time. They do very different things. So Windows, like BranchCache, it is in maintenance mode. It doesn't mean it's bad. It just means that it's pretty mature. There's still bugs that can happen. Microsoft fixes them. But it's on every single OS from Windows 7. Delivery optimization requires an internet connectivity. It's only for Windows 10. BranchCache is, I would say, stable in the way that it's not developed, so there's not so much that you need to read up on every month or every release. DO, you need to read up on every single release. And there's currently no HTTP integration or announced plans to do that in delivery optimization. So if you're using BranchCache to speed up SharePoint, etc., it's going to continue for a long time. But this is a good slide, I think, to describe what Microsoft's strategy is. It's probably extremely hard to see in the back. Let's see if I can zoom here. But these are the bits interfaces, the names. So I background copy callback. Do you see the DO interface name? So they basically made an exact copy of the COM interface for bits on top of DO. So for Microsoft, it's a switch of a button, and anyone that's like a software vendor that's creates bits jobs, they will just think they're creating bits jobs, but they don't. They're creating DO jobs. So they will, at some point in the future, say we no longer need bits because DO would do all of the transfer for us. But if that is in 5 years or 10 years' time, I do not know. So last slide. If you're not think you're not using DO, think again. You are. Use the Windows Analytics to figure out what you're actually getting the content from. Is it only internet downloads? Enable peer-to-peering. Read up on the policies and set them. BranchCache is here, so if you're using Configuration Manager, start using BranchCache because the content's not going to get any less. And you might think that you didn't need it before, but as you will start competing with all of the bandwidth with other technologies like DO at the same time, anything that you could take down on the Configuration Manager side will help a lot. And to make sure that you set your DO policies. Measure if that make any difference over a month, change them again, follow up, and change them again. And both of these technologies, Windows Delivery Optimization is actually the first consumer of LEDBAT. So when a Windows 10 machine is serving content with peer-to-peer, it's using LEDBAT on the outgoing connection. It doesn't use it on the incoming per se. So most of the problem when people have issues is because it's uncontrolled other server sources where it's getting the content from, not from other peers, because the peers are pretty good of setting, I'm using LEDBAT, So I'm not going to send too much data on that link. So make sure you evaluate the session. We do have 6 minutes for questions. I've prepared a couple of you for them, unless you come up with any of your own. But if there is any other questions, please let me know. Otherwise, I'll be around here. Yeah, so the question is, with LEDBAT, you said that Apple, they have an issue with, like, it's called, in the algorithm band, like, team, we call it latecomer's advantage. So if you join the crowd later, you have a theoretical power to push down all of the other connections. Meanwhile, you will not detect that there is other traffic. Because the traffic, it's kind of like if you're pushing your way into a elevator with your back, you don't know that you had lots of people behind you. But the other guys will see you, but you don't see them. So if you come in, but then some other guy comes in, then you have to back down too, but the other guy doesn't. Yeah, so if you're the last guy, you will consume all of it, which is the bad part. So, but Microsoft did fix this, and they actually did add to the RFC, so Apple, they should just update their own algorithm. They basically update on the RTT a little bit more often. So the Windows team did quite a few smart things there. Any other questions? Who's having problem with Wi-Fi and peer-to-peering? Patch Tuesday? No problem. It's a pretty common one otherwise. Yeah? Switch storm control is another big one. So BranchCache is using multicast to find other peers, so when they all start sending out lots of multicast packages, the switch, the default values on the, especially the Cisco switch, is the default action is, if you enable it, is to drop the port. That's not very good. We had a customer, they had 12,000 machines, they dropped every single port. And what do you think when you can't get to your port? Who do you call? Help desk. I had a pretty bad day. So the best is to set, you can still use storm control, but set it to drop the packet, don't drop the port, and maybe set it up a little bit higher than the default. I think the default is like 20K on the entire switchboard, which is very low. Any other questions? Question could be a Swedish too, I can translate. No? All right, thank you very much for attending.